Welcome to this explainer. Today, we are demystifying Kubernetes admission controllers. We'll start from the absolute basics of the request flow and then go completely down the rabbit hole into webhook policy enforcement. Let's get right into it.
Here is a quick look at our roadmap. We are looking at the request flow, why RBAC isn't enough on its own, and then we'll introduce the admission webhook. After that, we'll break down validating versus mutating webhooks, tackle some troubleshooting, and wrap it all up with a mental model you can actually use.
All right, part 1, the Kubernetes request flow. So, picture a simplified API request flow. A request starts at the client, hits the API server, runs through authentication, then authorization, which is usually your RBAC, and then it hits admission. Finally, if all goes well, it's persisted to etcd. Notice exactly where admission lives in this chain. It's that final, absolutely crucial policy checkpoint right before an object becomes the cluster's official state.
I love thinking about this flow like security at a super exclusive club. Authentication is the person at the door asking, "Who are you?" They're checking your ID. Then RBAC steps in and asks, "Okay, but are you on the VIP list?" Admission, though, admission is the metal detector. It's looking at you and asking, are the specific items in your pockets actually allowed in here, and do we need to alter or confiscate something before you step inside?
Moving on to Section 2, let's talk about why RBAC is not enough.
Here's the thing. RBAC is great at controlling who gets to act, but it is completely blind to the actual contents of the Kubernetes object. Literally blind. If a developer has RBAC permissions to create a deployment in production, RBAC just waves them right through. It cannot look inside their YAML file to see if they're actually following your organization's specific operational rules. And we all know organizations have a ton of rules, right? You probably mandate that every production container has CPU and memory requests so a runaway pod doesn't crash a node. Or maybe you strictly require images to be pulled from an approved internal registry. You might ban privileged containers entirely or demand specific cost center labels for billing. RBAC can't check any of that. Admission is the checkpoint that actually enforces these real-world requirements before anything gets saved.
Which brings us to Section 3, enter the admission webhook. To actually enforce all these complex rules, Kubernetes uses a webhook. Think of it as a way for the API server to just hit pause on a request, reach out to an external service, and ask for a real-time decision. The webhook looks at the incoming payload and says, allow, reject, or mutate. And unlike a standard controller that just kind of sits in the background watching the cluster, a webhook jumps directly into the live API request path.
Section 4, validating versus mutating webhooks. This is where the strategy splits. So, you have two very distinct types of webhooks. A validating webhook is your strict gatekeeper. It checks if an object complies with your policies and then simply allows it or rejects it. No compromises. A mutating webhook, on the other hand, is more like an assembly line worker. It intercepts the object and can actually tweak or modify it automatically before Kubernetes stores it. Imagine one of your developers submits a YAML file, but they forget to set resource limits. A validating webhook is going to immediately reject that request. It'll throw a wall of red text right back at their terminal saying something like, deployment rejected, production workloads must define CPU and memory requests and limits. Boom. The developer is forced to go back, fix the manifest themselves, and try again. But what if you want to save your developers from having to memorize 100 different organizational rules? That is the magic of mutating webhooks. If you've got 50 teams deploying hundreds of workloads, a mutating webhook can just automatically inject a required security context or attach a mandatory sidecar container right on the fly. It enforces your standards centrally, which completely removes that cognitive load from your developers.
Section 5, troubleshooting and controller differences. Basically what happens when things break.
For your technical interviews or really just your daily operations, you absolutely must internalize this difference. Admission acts on an API request before the object is persisted. It asks, should this be accepted right now? A controller acts continuously after objects exist. It asks, does this existing deployment actually have the 3 replicas it requested? They both automate your cluster, sure, but they solve entirely different problems on the timeline.
Now here's the slightly terrifying reality of this architecture. Because an external webhook sits directly in the live API request path, if it fails, it can break API requests entirely. Let that sink in. If your external webhook service goes down, the API server can't get a decision, and developer deployments will stop dead in their tracks.
So, when you inevitably hit a webhook availability error, you need a systematic runbook.
First off, always suspect your TLS certificates. Expired certs or bad CAs are the usual suspects. You'll want to check the admission webhook configuration, verify the service endpoints, and dig into the webhook logs. But most importantly, check your webhook failure policy. That policy dictates whether a request is strictly hard rejected or allowed to just pass through when the webhook goes offline.
Finally, Section 6, the ultimate mental model.
Let's lock in everything we've covered today. This is your mental framework for cluster governance right here. Authentication asks, who are you? RBAC asks, are you allowed to do this? Admission asks, is this specific object acceptable, and should we change it? And then the controller asks, does the cluster continue matching this desired state after the object is created?
I want to leave you with this final provocative thought. Let's say your cluster has RBAC dialed in perfectly, but without admission control, is your desired state truly secure? You might have the front door locked down, but if you aren't inspecting the actual workloads crossing the threshold, you're leaving a massive vulnerability wide open. Take a look at your own environments and think about how you can use webhooks to harden your platform. Thanks for diving into this explainer with me. I hope the Kubernetes request flow is now crystal clear for you.